All right, so today we're going to talk about the integral of secant of x. So there's a cheap way that people usually do this that I'll show you first, and then we'll do it a way that I'll call quote-unquote honest. So here is the way that people typically do this. They go ahead and say, okay, we're going to let u equal secant of x, which would make sense, but plus tangent of x. Which is a little weird because we don't have a secant of x plus tangent of x. But what we can do is that we can make one. So we can take this, and I can rewrite this as the integral of secant of x. And so what I can do is I can multiply by secant of x plus tangent of x. And then, of course, I also have to divide by secant of x plus tangent of x. And so if I simplify that just a smidge, that'll be the integral of secant squared of x plus secant of x tangent of x, all divided by secant of x plus tangent of x. dx. All right, now if you want to look back up here at our u, we now have a secant of x plus tangent of x. So what's du? Well, du is going to be the derivative of secant of x, which is secant of x tangent of x plus secant squared of x. Now, wouldn't you just know it? That's exactly what we've got here in the numerator. In other words, in order to put this secant of x plus tangent of x here that we needed in order for this u substitution to possibly even begin to make a little bit of sense, we accidentally just happened into this. And so this is now, if you look at it, this is the integral of 1 over u du, just straight up. And so that's the natural log of the absolute value of u plus c. And so that, if I go ahead and write it out, that is going to go ahead and be the natural log of the absolute value of secant of x plus tangent of x plus c. And that is the integral of secant.